Okay, good afternoon. My name is Shunichi Ono. I'm a manager of the engineering department at the Yokohama rubber company. I have been involved in the development of offshore hoses for 15 years. Today, I'm going to talk about the design feature of the ship-to-ship transfer hoses and newly developed pneumatic fenders. See? This one? No, here. This one?
Yes.
Okay, I see.
It's a laser too.
Only here.
Yes.
Okay, sorry. I'd like to begin with the ship-to-ship transfer hoses. We developed the ship-to-ship hoses in 1989. Since then, we have supplied 3,500 hoses to the market. So our ship-to-ship hose is well known among the operator as the field-proven product. Okay. Our ship-to-ship hose have several unique features. The most significant feature is the helix wire-free design. The helix-free wire design is more kinking tolerant compared to the conventional design. This figure shows a comparison between the conventional design and helix wire-free design. In the conventional design, the carcass is reinforced by the helix wire. Here is the helix wire. So the helix wire is spiral around the carcass. So once the hose is kinked like this, hose must be retired because the kinking causes a permanent deformation of the helix wire. So here is the helix wire-free design we employed for the ship-to-ship hose. Okay. The hose doesn't have the helix wire. Okay. So the operator can continue to use the hose even after the hose is kinked like this. Okay. Because the hose recovers its shape when the internal pressure is applied to the hose or the bending force is removed. So helix wire-free design has the advantage of kinking tolerance. Okay, so many operators ask us this question: is this okay to kink Yokohama hose? My answer is yes and no. Okay. If you kink a hose once a day, of course, my answer is yes. But if you kink a hose 100 times a day, my answer is no. So this figure shows our recommendation on the kinking. Okay. For example, when you drive a car, you try to avoid sudden stop and sudden start like this. However, in this situation, of course, nobody tries to avoid sudden stopping. Okay. Of course, drivers should stop suddenly in this case. Same thing can be said to our ship-to-ship hose. Okay. Sometimes operator kinks the hose accidentally during the maneuvering the hose for the tanker connection. So the kinking under an unavoidable situation is of course okay. However, the frequent kinking in the normal operation should be avoided. Okay. So the ship-to-ship hose must be designed to withstand repeated kinking. Okay. It's not so easy to design this kind of hose because the repeated kinking causes fatigue on the reinforcement. Okay. This figure shows the kink performance test. Result of the test confirm our ship-to-ship hose can withstand 20,000 kinkings. Okay. So we took out the sample from the kinked area after 20,000 kinking and conduct the material test on the sample. Here are the result of the test: adhesion between layers, strength of the reinforcement cord, property of the tube lining, appearance of the tube lining were acceptable level. We observed some minor crease mark on the tube lining at the folded part of the hose. However, this level of minor crease mark doesn't affect the performance of the hose. Okay, I will show the video of the kink performance test. Also the kink 20,000 cycles. So ship-to-ship hose must be designed to withstand the kinking like this. Okay, so next, this slide is a bit complicated. Our original ship-to-ship hose has an electrical semi-continuous property. So the electrical semi-continuous hose minimizes the risk of electrostatic discharge and will not produce inductive sparks by the interruption of the straight current. So the electrical resistance of the hose is low enough to avoid electrical static charge, but too high to transmit the large straight current. Okay. Here is our electrical resistance in our original design. Unfortunately, this range of the electrical resistance does not conform any international standard. So we stopped supplying this hose in 2014 because this hose was not supported by OCIMF, ship-to-ship transfer guide. We are now developing the new electrical semi-continuous hose, which conform international standard ISO 8031. So the electrical resistance of the new hose will range between 25,000 ohm and 1 million ohm per hose assembly. So the new hose will be categorized into both conductive hose and discontinuous hose, like this. So we will put this hose into the market next June. If you use this kind of hose, you don't need to care about electrical static charge or inductive sparks. Okay, let me explain the structure of the semi-continuous hose briefly. This figure shows a cross-section at the hose body. Okay, so the carcass is covered with outer cover. Here is outer cover. So outer cover consists of the outermost layer, special rubber, and breakers. So segment in yellow indicates the special rubber, which is specially developed to have electrical semi-continuous property. So this special rubber is firmly bonded to the fitting and connects the fitting at the both ends electrically. So this structure gives a unique electrical property to the hose. Okay, so our ship-to-ship hose has the advantage of a high burst resistance. So the minimum burst pressure defined in the EN standard is 4 times rated pressure. It's 60 bar. In our Yokohama specification, the minimum burst pressure is 5 times rated pressure. It's 75 bar. The actual burst pressure in the prototype hose approval was 98 bar. It's 60% higher than the minimum burst pressure defined in the EN standard. I'll show the video of the burst test. Our hose has an advantage of a high burst resistance. Hose is pressurized now. Okay, hose burst up here. At the end of the shoulder ply, this is the perfect burst mode. Okay, here. Next, I'd like to touch on the safety valve requirements. Okay. In the safety valve for pneumatic fender, the effective area is very, very important. Okay. The segment in pink indicates the effective area of this valve. So the effective area is directly related to the air release capacity. So the large effective area can release the air from the fender quickly to prevent the excessive high pressure or rupture when the fender is overcompressed. Okay, so is this a safety valve? Answer is yes, but this valve is activated at preset pressure, but small safety valve is not suitable for the pneumatic fender because the air release capacity is too small to prevent the internal pressure from rising when the fender is overcompressed. So if your fender is equipped with a small safety valve like this, of course, this valve is activated at preset pressure, but internal pressure continue to rise and may rupture the fender. So the size of the safety valve must be selected based on the air release capacity. Next, I'd like to explain the new flange opening. Okay. This is a picture of new flange opening. Okay. This flange opening facilitates inspection of the safety valve. Okay. So this flange opening is specially developed for the vertical pneumatic fenders. Okay. The operator spends a lot of time and money on the inspection of the safety valve. Prior to the inspection of the safety valve, operator have many things to do. The first, operator removes the water from the fender, then bring a fender ashore to where with the sinker. Next, operator deflates the fender like this to remove the safety valve from the fender and set the safety valve in the test chamber for the inspection. After the inspection, operator have to send the fender back to service in the reverse order. These operations cost much, and there is a risk the fender is damaged during the handling like this. So our new flange opening allows operator to inspect the safety valve without removing the fender from service. So the operator can inspect the safety valve easily under the condition shown in this picture. Don't need to bring the fender ashore for inspection. So this figure shows the cross section of our safety valve. New flange opening, which is installed at the top of the vertical fender. The new flange opening consists of chamber here and manually operated shutoff valve. The shutoff valve makes the chamber open to and shut off from the inside of the fender body. When the fender is in service, shutoff valve is open. So internal pressure of the fender is transmitted to the safety valve. So the safety valve can be activated when the excessive pressure is applied to the fender. When the inspector inspects a safety valve, shutoff valve is closed like this. So chamber is created at the back of the flange opening. The operator can apply the pressure to the chamber to confirm if the safety valve is activated at preset pressure. So if the replacement or further inspection is necessary, operator can remove the safety valve from the flange opening without deflating the fender. So the new flange opening allows the operator to replace the safety valve easily. Okay. So I'd like to move on to the next topics, mega fender. Okay. This is a picture of the world's largest pneumatic fender. We developed this fender last year and named mega fender. Okay. He is my colleague, Mr. Yamada. If you compare him with the mega fender, you can understand how big it is. You may think it's too big. Such a big fender is not necessary. I agree with you. When we developed 4.5 meter fender 40 years ago, most operators told us same thing. It's too big. 3.3 is enough. But now, today, the 4.5 meter is a normal size. We accept the same thing will happen to our 6 meter fender. What is important is to develop it for the first time in the world. So if you have a good idea for the application of this kind of big fender, please let me know. Okay, so here is the basic specification. The weight of the fender body is approximately 71 tons, and the weight of the fender with chainnet is 20 tons. The initial internal pressure has been set at 70 kilopascal. So mega fender have 4 features: long standoff, high energy absorption, low stiffness, and low hull pressure. I explain them one by one. Okay. The most significant feature is, of course, the long standoff. This graph shows the comparison between the energy absorption and standoff between the conventional 4.5 meter fender and the mega fender. Okay. Conventional 4.5 meter fender provides a standoff of only 1.8 meter after absorbing the energy of 4,752 kilonewton. Mega fender can provide 3 meter standoff after absorbing 6,300 kilonewton meter. So this means that the mega fender is suitable for the project which needs the long standoff. And the mega fender has the advantage of low stiffness. Low stiffness means very soft. Okay. Normally, fender gets stiff when the initial internal pressure is increased. But mega fender is specially developed to have a low stiffness. So this graph shows the comparison between the reaction force between conventional fender and the mega fender. As you can see from this graph, the reaction force of the mega fender is almost same as that of conventional 4.5 meter fender. And mega fender has the advantage of low hull pressure. This is also important for the big fender. This graph shows the comparison in hull pressure between conventional 4.5 mega fender. Hull pressure of the mega fender is lower than that of the conventional fender when the deflection exceeds 2 meters. Okay. I'd like to explain the unique structure of the mega fender. We employ the unique structure to develop the mega fender. Okay. Okay. So we fabricate 4.5 meter by 14.2 meter fender, and the fender is inflated by the initial internal pressure and change its size to 6.0 meter by 11.5 meter. As you know well, YOKOHAMA fender is very strong and durable, so it's not so easy to expand the fender largely at low pressure. We employ the new design, new material to achieve this large expansion. Okay. Let me explain the mechanism of the large expansion briefly. So we use the change in angle of the reinforcing cord to expand the fender largely at low pressure. Okay. This brown line indicates the reinforcing cord. We apply the reinforcing cord with this angle like this. So when the pressure is applied to the fender, the angle of the reinforcement cord is changing like this automatically until the larger pressure force and the axial pressure force is balanced. As a result, fender expands its diameter from D0 to D1 and shrink in length from L0 to L1. This is the mechanism of the large expansion. Okay. As you can see from these two pictures, fender expands its diameter and shrink in length when the internal pressure is increased. Okay. Okay, 1 minute, okay. We conduct the burst test on the full-scale prototype. Burst pressure is 523 kilopascal. Please look at the burst position. This is a perfect burst mode. Fender burst at the top of the body. If the strength of the fender is affected by the new design or large expansion, fender would burst at the shoulder. So this is the perfect mode. So this is the last slide. We conduct the burst test on the full-scale prototype. Like this. Okay, thank you for attention.
Thank you, Mr. Ono, for a very comprehensive presentation on the design features of newly developed hoses and fenders. Surely the videos and the photos you showed us helped us all better understand the characteristics of this equipment. We have 2 questions.
Okay.
First one is by Mrs. Zoe Wilsmith from Unipec UK. What can cause a fender to deflate? And should a fender be retired if it has a history of deflating?
History of deflating. I can't understand the history of deflating. Retire if?
Yeah, this is strange. But anyway, what can cause a fender to deflate?
Deflate.
Deflate.
Compressed or deflate?
Decompressed.
Sorry?
Decompressed. Decompressed.
Decompressed? Lose air, okay.
Lose air.
No, you don't need to retire, of course, the fender. You can apply the pressure. No?
Are there any specific things that we can see that they can cause a fender to deflate so that we can avoid them? I think that's part of the question. Or...
So basically, you have to keep the internal pressure. So if the internal pressure is dropped, you have to apply the pressure.
Okay, so question number 2, is the size of the valve related to the size of the fender? What should be the minimum acceptable size of safety valve for a fender?
2.5.
Okay. Next question. In case the outer layer of the fender is locally damaged, is this repairable? Will the fender recover his full strength?
Yes. The answer is if the damage reaches the reinforcement cord and reinforcement cord is damaged, the fender must be retired. But if the damage doesn't reach the reinforcement cord, you can repair, of course, and the strength remain unchanged.
Okay. So, okay, one question. The gentleman there.
Thank you. Hi, Emmanuel Aguirre from Exmar. First of all, I wonder if introducing fenders of 20 tons weight is advisable for ship-to-ship operations.
Sorry?
Introducing fenders of 20 tons weight, totally, if it is advisable for ship-to-ship operations, providing the ship's equipment and so on. But I was wondering if you have any information on the foam-filled fenders as well.
No.
No.
We don't supply the foam-filled fender.
You don't supply?
No, only a pneumatic fender.
Okay, thank you.
So, conscious of the time, I would suggest that we keep other questions for the end of the session.
Okay.
So, please give a round of applause for Mr. Ono. Thank you.
Thank you.